All right, students. So today we are going to learn about similarities in the area of triangles, okay? Now, most of you may have seen this before, but now we are going to do questions that require more creative approaches. Let's take a look at the worksheet. Now, students, let's do a quick revision. I just want to remind you, before we start, okay, the area of a triangle is found using the formula half times base times height, right? So usually the base is at the bottom and the height is 90 degrees to the base. However, please take note, okay, just be reminded that the base does not always have to be at the bottom. If I want to call this the base, I can, as long as I draw a line which is 90 degrees to the base, I can just call this the height. Okay, one more thing. The height can also be outside the triangle. If this is the base, the height is outside the triangle. Do you notice? So what is the most important thing? The most important thing is the height must always be 90 degrees to the base. So that's just a quick reminder there before we start. Now, student, this is the butterfly concept. We call it butterfly concept because it looks like the wings of a butterfly. Now, we have a set of parallel lines. Okay? And if I were to draw this yellow triangle, and I were to draw this green triangle, you will notice that both of them share the same base. And guess what? Where is the height of the yellow triangle? It's over here, 90 degrees to the base. The height of the green triangle is 90 degrees to the base. And because these are two parallel lines, the distance between them is the same. Both of them will have the same height. And what I can say is that the area of the yellow triangle equals to the area of the green triangle. If I were to call this area R, you see P, Q, R, right? The overlapping area, let's call it R. Then what can I say about that? The yellow triangle is the area P plus the area R. And that equals to the green triangle, area Q plus area R. If you cancel out the overlapping area R, you will realize that the area P equals to the area Q. So students, next time when you spot a butterfly, then please remember, as long as you have parallel lines, as long as they share the same base, then the area of P will be equal to the area of Q. The wings of the butterfly will have the same area. Okay, students? Any questions? Raise your hand. Anyone? Okay, if that's the case, let's look at example 1. Students, I have just taught you the butterfly concept. Can you use the butterfly concept to tell me what's the answer to this question? I give you maybe 1.5 minutes is enough already. Type your answer in the chat. All right, Aiden, you are the fastest one. Correct. Try to spot the butterfly, students. 30 seconds left. Ah, Nicole, try again. Well, Nicole, you're correct. Well done. Gwen, is that a typo error, Gwen? Haha, Gwen. So far, 3 of you got it. Aiden, Nicole, and Gwen. Good job. Okay, Aiden, Nicole, and Gwen, you got it. Students, by now, if you cannot get the answer, then it looks like you will not be able to get it. So let's go through this, okay? Everyone, what do you need in order to find the butterfly? You need a set of parallel lines, and you need 2 triangles that share the same base. Take a look at this, students. What if I were to draw a line from here to there? Do you notice? Okay, let's take a look at the line AC. Do you notice that they are parallel because you are cutting a square into half? The corner of a square is 90 degrees. If you cut it in half, this is 45 degrees. This is also 45 degrees. These 2 lines are definitely parallel. Yeah? Look here. I can draw a triangle like this. Okay, look at this red triangle. And let's look at this blue triangle. Do you notice that the red and blue triangles, they share the same base? They share the same base. So what happens to the butterfly wings? Do you notice that this area here is one butterfly wing and this area here is the other butterfly wing? If you want to call it your P and your Q, then it will look like this diagram, you see? P and Q, the butterfly wings, right? So students, if I draw this for you, those of you who have not given me your answer, can you now tell me what's your answer? Alistair, you got it. Those of you who have not given me your answer, okay, Vishwam, Malcolm, Caden, Andriel. Oh, Vishwam, try again. The area P equals to the area Q. They ask you to find the area of the shaded region, right? Can everybody tell me what's the area of the shaded region? Not much work. You don't even need to do workings, actually, right? Just type your answer, everyone. Okay, let me ask Andriel. Do you have an answer?
Is it 32?
Yes, it is 32. Very good. Well done. And okay, students. So the answer is 32. Why? Because if you can see, the area P equals to the area Q, right? So what we're going to do is this. We are going to bring this shaded area and we are going to move it into this area. Okay? So this becomes the shaded area now. So we are effectively just trying to find half of the square. Yes? We are just trying to find half of the square. So we can say that the shaded area is the big square divided by 2, which is, there you go. Okay, anyone has questions? Raise your hands. Hello, Talia. Yes, Talia, you're here. Very good. Okay, anyone has any questions? Let's move on. Okay, the next thing we would like to discuss is the ratio. Now, students, as you know, if two triangles, okay, let me draw two triangles. Okay. Let me draw triangle. Let me draw triangle A here and triangle B here. Now, if you look at triangle A and triangle B, I'm going to say that, okay, they have the same base. They have the same base, the same length. Their bases are of the same length. They also happen to share the same height. Because if I were to draw a dotted line like this, 90 degrees, triangle A and triangle B will have the same height, h. If they have the same base, and if they have the same height, then if you want to find half times base times height, they will have the same area. Correct? Now, what if the triangles have the same height? Okay, let's say they have the same height, but what if I told you that triangle A and triangle B have the same height but different bases? Let's say this triangle has a base of 10 cm. Okay, let's say the height. Okay, let's say the height is, let's say, 5. Okay, and triangle A has a base of 4 cm. Then what is the area of triangle A? The area of triangle A will be half times base times height. And the area of triangle B will be half times the base times the height. Right? And you notice the ratio. Let's look at the ratio. Triangle A is to triangle B. Triangle A has an area of 10. Triangle B, 25. If you simplify the ratio, you divide both sides by 5. Divide by 5, you get 2. Divide by 5, you get 5. The ratio is 2:5. Now, I would like you to look at the base, 4 cm and 10 cm. You simplify it, divide it by 2. 4 divided by 2 is 2. 10 divided by 2 is 5. What do you notice about the two ratios? You notice that the ratio of the area is the same as the ratio of their base. Correct? So, students, if you see two triangles sharing the same height, then the ratio of the base is going to be the same as the ratio of the area. Okay? Any questions? Raise your hand, students. Any questions? Okay, so now that you understand this concept, the ratio of if they have the same height, the ratio of the base must be the same as the ratio of the area. Look at this diagram. Both of them have the same height. See? Both of them have the same height. They are telling you that AB equals to 3/7. AB is 3 units. AC is 7 units. And what does it mean? That means BC must be 4 units. So immediately I can tell that the ratio of AB is to BC is 3:4. This is the ratio of their base. Since they share the same height, what does it mean? That means the ratio of their area must be the same as well. Correct, students? So I can say that 3 units equal to, okay, because they already gave us the area of triangle ABD. So I will allocate 3 units to this area and 4 units to the other area. 3 units is 31.5. 1 unit, you just divide by 3. And finally, you can find out the area of BCD. The area of BCD must be 42, according to the ratio. Anyone has questions about this, students? Okay, no questions. Let's look at example 3. Over here, what concept are we learning? Okay, let me introduce the concept. Look at this rectangle here. Let me ask Malcolm. Okay, Malcolm, let me ask you something. We have a rectangle. If I were to draw a line to cut this into half, okay, what shape am I forming inside the rectangle?
Triangle.
Triangle. Do you agree that this triangle is actually half of the rectangle?
Yes.
Very good. Now, if I were to draw another rectangle like this, and let me cut it like this, do you also agree that this triangle is half of the rectangle?
Yes.
Okay, very good. I'm going to join them. Oh, whoops. Okay, now I'm going to draw another one. I'm going to draw another rectangle like this. And I'm going to draw a triangle inside. Like that. What fraction of the rectangle is the triangle?
Which triangle?
This triangle. What fraction of the rectangle is this? Say again.
Half.
Do you know or you don't know?
Half.
Half. Very good. You are correct. Why? Okay,
Because if you split the thing into two rectangles, then
yes, very good. If you split it like that, you already know this is half. You already know this is half. That means the entire triangle is half of the rectangle. Well done. Now, what if I do this? What if I do this? I draw a triangle like that, and I draw another triangle like that. Then let's call this A and let's call this B. If I take A plus B, am I going to get half of the rectangle also?
no.
No, let's try. If I split this like this, can I say that A is actually half of the rectangle?
Yes.
And B is also half of the other side.
Yes.
So now let me remove this line. Can I say that A plus B is going to be half of the entire rectangle?
Yes.
Yes, very good. Okay, well done, Malcolm. So Malcolm, if I say A plus B is half of the entire rectangle, now you look at the diagram here. 10.5 plus 17.5. What would that give you?
Half.
Half of the entire rectangle, right?
Yeah.
Do you think you can find the answer for this question? Okay, I'll give you 1 minute. Okay, students, everybody take 1 minute. Can you all please write down the answer in the chat? What is the area of the rectangle ABCD? Yes, correct. Anbriel got it. Kaden, Vishwam, very good. Aiden also got it. Gwen? Okay, Gwen, come help me out here. All right, Gwen, let's try to find the answer, okay? Gwen, look at the yellow triangle. Okay, the yellow parts. When I add them together, what fraction of the entire rectangle will I get? Gwen, do you know?
No.
You don't know. Okay, Gwen, if I were to draw this, what fraction of the rectangle?
Oh, wait, half.
Okay, yes, this is half, right?
Yeah.
Now, if I draw another rectangle like this, and I draw another triangle like this, is this also half?
Yeah.
So when I add up those two triangles, do I get half of the entire figure?
Yeah.
Yes, correct. So these two yellow parts, when I add them together, I'll get half of the entire rectangle, yes or no? Wayne, can you tell me what is the area of the rectangle ABCD?
No, ABCD. 10.5 plus 17.5 times 2.
And what do you get?
Uh,
28 times 2. What do you get?
56.
Well done. So how? Is there any questions about this?
No.
Okay, well done, Gwen. So students, whenever you see triangles inside rectangles, as long as they are touching the corners of the rectangle, and as long as they are touching the circumference, not circumference, the perimeter. Okay, so what are the rules? You must start from the corner. You must touch the perimeter, and then you go back down to the other corner. Okay, you must be touching all these 3 points. If not, if not, it will not be half. All right. Okay, moving on. Example 4, everyone. Okay, so here we have 2 triangles and a rectangle, and that's all they are telling us. They just gave us 20 cm and 30 cm. They did not tell us what is the height. Okay, we already know that. I already informed you. That as long as the height, as long as it is as long as the height is 90 degrees to the base, then it will be the correct height. The height always has to be 90 degrees to the base. If I were to call this the base, then this is the height. If I were to call this the base, then this is the height. The problem is we already know what is the length here, but we don't know what is the length here. We know the length here, we don't know the length here. How are we going to find the area of the triangles? I also can't find the area of the rectangle, yes or no? Because there's too little information. So does anyone have any idea how to do this? Anyone want to try? Or anyone have an idea that you want me to try? What could we do in this case, students? Think about it for a while. Any ideas? Yes, Aiden, you have an idea? Come, share with me your idea.
Yes, a bit. I
Sorry?
tried doing it, but I got an answer, but it's quite bad.
Oh, decimals?
No, it didn't give me the sums.
What's your answer?
I think my answer should be 460, I think.
60.
460.
Okay, okay. So did you draw any additional lines or do you slice it into?
Nothing.
Sorry?
Nothing. I didn't do anything else.
So how do you get 460?
I tried using Pythagorean theorem.
Pythagoras theorem, huh?
Yeah.
Okay, okay. Good try. It might work. Thank you, Aiden. So students, what he did was he tried Pythagoras. Like for example, maybe he can call this X and call this Y, right? But you know, there's too many variables. Like you want to call this A and you call this B, then you say this square plus this square equals to this square. But of course, there's too many variables and we'll never know the exact answer. You can only guess in this case. So Pythagoras theorem will not really work. Okay, I tell you what, why don't we do this? Let us create a mirror image. Oh, yes, Nicole, you raise your hand. You have any idea?
I was just wondering if you get like the area of like the triangle of like the 30 cm one and then the area of 20 cm one, doesn't it equal to like, isn't like the difference 30 cm minus 20 cm?
Isn't it what?
Like the difference 30 minus 20.
But 30 and 20 is the length, right? Not area, right?
Yeah.
Yeah, so the difference in the area will not be 10. So why not we create a mirror image, everyone? Let's take a look here. I'm going to draw a line here. Okay, let me draw a line here. And another line here. Okay, let me duplicate the exact triangle that we are seeing. Okay, so this is 90 degrees, this is also 90 degrees. And let's draw a line here. And let's draw a line here. All right, everyone. Do you agree that this triangle is an exact duplicate of this triangle? And this triangle is an exact duplicate of this triangle. That means the areas are the same, right? Now, students, if I were to compare this 30 cm, I will also know that this length that I've duplicated is 30 cm. And for the 20 cm, I will know that this is 20. Okay? And since the area of the triangles are the same, it is the same as this. This is the same as the other triangle. And what happens next? That means that the area of this rectangle should also be the same as the area of this rectangle. Okay? So students, can you type your answer? What is the area of the rectangle? Yes, Vishwam, you got it. Who else? Nicole, you got it. Malcolm, well done. Hey, Andriel, let me ask you something. Okay, Andriel, tell me, can you find the area of this rectangle?
Yes.
What times what?
20 times 30.
So you type, your answer is 100.
Oh, I thought meant to find the whole
20 times 30, what's the answer?
600.
There you
I
go.
thought meant to find the whole rectangle.
Oh, this is created by me. This is just our working, right or not?
Yeah.
So what does the original question look like? The original question only has one rectangle, which is this rectangle, yes or no?
Mm-hmm.
Ah, so you understand why the answer cannot be the entire rectangle?
Okay.
Yeah, this is part of the original question. So we must stick to the original question, yeah?
Mm.
Okay, well done. So students, anyone have any questions? Raise your hand, please. Okay, sometimes we have to draw our own diagram. We have to create an extension of the diagram. Okay, so we need to think out of the box, especially in cases like that when we don't even have enough information. Okay. Let's look at example 5, everyone. So they're telling us the perimeter of the parallelogram. But they also told us that AE is 9 cm, AF is 7. They're asking you to find the area of ABCD. Now, students, when I look at this shape, it is a trapeze. It is like a trapeze. It's a quadrilateral. Okay, it's something that I'm not comfortable with working. I'm not comfortable working with. Why not we get rid of this shape? Let's slice it up. And let's slice it up like that. And we have formed two triangles, which are much easier to work with. Remember, this whole topic is about areas of triangles, right? So students, now we have sliced it up and we have gotten ourselves two triangles. if we were to look at the triangle ADC, and you look at the triangle ABC, don't you think that what we have just done, okay, when we have drawn that line to slice the diagram, we are actually cutting the diagram into half, yes? We have actually sliced the entire parallelogram into half. So now, if I were to ask you, what is the relationship between ADC and ABC? We can say they are equal because the red line AC has already cut the parallelogram into half. So I can say that the area of triangle ACD equals to the area of ABC. Okay? That means half times the base of ADC times the height, which is given in the question. Okay, so this is the base. And this is the height. So half times base times height equal to half times, now this is the base, BC, times the height, 90 degrees, given by the question 9, right? So if we simplify this, okay, let's get rid of the half. Okay, half and half, we can just cancel, we can just divide both sides by half. But if I want to get rid of this 7, I'm going to divide by 7 on both sides. What will I get? Okay, let's say the 7 is already gone because I divide by 7, right? So we'll get CD equal to 9 divided by 7. 9 over 7. 9 divided by 7 BC. There we go. So we have managed to make a comparison between CD and BC. So far, does anyone have any questions before I move on? Okay, no questions. If you have questions, just raise your hand. Click the button in Zoom. Raise your hand, okay? Now, students, they told us the perimeter is 80, right? That means this plus this plus this plus this equal to 80. What if I want to find this plus this? Okay, let me ask Kaden. Kaden, if I just want to find BC plus CD, how do I find it? They already told you the parameter is 80. Yes or no?
Just now I cannot hear because my thing disconnected.
Okay, okay. The question is telling us that the entire parameter is 80. So if I just want to find BC plus CD, what is it?
80 DR2.
Very good, very good. Let me write it down. So BC plus CD should be 80, the parameter divided by 2. It is half of the parameter, and we will get 40. Now, we already know that CD equal to 9 over 7 of BC. So let me write it down. BC plus 9 over 7 of BC equals to 40. Kaden, help me to add. What is BC plus 9 over 7 BC?
40.
Can you help me get the fraction?
Oh, fractions.
This plus this. How should I simplify? 1 BC plus
1 BC plus 9 over 7 plus 1 BC.
So what is 1? What is BC plus 9 over 7 BC? In terms of the fractions.
Uh,
Okay, this is 1 here, right?
yeah, there's another one there. So
Can-
9/7 plus 2 BC.
Can I change the, okay, the number 1, can I rewrite it? In order to add fractions, you must make sure the denominator is the same. Can you tell me what denominator should I be using here?
7.
Okay. What numerator here?
Numerator is uh oh yeah, 7.
What is 7 divided by 7?
Equals to 1.
Very good. Can you help me to add these two together? What do I get?
Uh,
Just add this first.
23/7.
How you get 23?
Oh, wait. No. 7/7 plus 9/7 equals to 15/7 equals to
Stop.
equals to
Don't want mixed number. I want improper fraction. Tell me improper.
okay.
Yeah.
So 15/7.
No. 7 plus 9.
Oh wait, no, 16/7. Careless.
Okay. So now we know this. Can I find BC now?
Yeah.
What should I do?
BC equals to
Get rid of this.
40 minus 16/7.
Minus. This is times.
Oh yeah. Divide. Sorry.
So let's divide both sides. Let's divide both sides by 16/7. Correct? So I cancel this because it becomes 1. It just becomes 1. So now we have, instead of divide, what should I do?
Times
Times what?
7/16.
Okay, good. Now let's simplify. This,
40/1.
huh?
40 becomes 40/1.
Okay. Actually not
And then
important to write that.
oh
So can I divide both of them? Which number can I divide them by?
just to make it easier, just divide by 2 first.
Okay, can we just skip to 8?
Okay, sure.
40 divided by 8. What do we get?
40 divided by 8 equals to 5. And then 16 divided by 8 equals to 2.
Okay. So can you give me the final answer?
35/2.
Yes, correct. Now that will give us 17.5 cm. Okay. So now we managed to find the length of BC. 17.5 cm. They are asking you for the area of ABCD. Okay, so area ABCD equals, okay, you already know BC, 17.5. Do you think you can find the ABCD, the entire area?
Yes.
Okay, tell me how.
17.5 plus 17.5 plus the DC plus AB.
You finding area or you finding parameter?
Oh wait. 17.5 times DC.
What is DC?
Uh
I don't think
DC is 9/7 of BC.
you want me to go and find DC. Don't waste time lah. Don't need. Can you find the area of this triangle first? Okay, what is the area of this triangle? Tell me the working. Half times that.
Half times base and height.
Okay, tell me half times what?
Half times BC times 9.
Okay, so half times 17.5 times 9, right?
Yes.
So once you find the area of the green triangle, can you find the area of the entire parallelogram?
Yeah.
Okay, what? How to find? Green
Half
triangle.
half times 9 times 17.5 equals to
Let's say it equals to 100. Okay, I know it is not 100, but let's say you found is 100. Then after that, what do you do?
I calculated it out. I think it's it's 157.5.
Okay, fine. So 157.5 is what? The area of what? The green triangle?
Green triangle.
Then after that, what do you do?
After that, 157.5 times 2.
Very good. So green triangle times 2 equals to the parallelogram. Well done, Kaden. You are correct. Okay, so let's work it out, students. Okay, students, because we already cut this parallelogram into half. Okay, so if you can find one of these triangle, you just times 2, you'll get the parallelogram. So ABCD equals to half times base times height. But don't forget, you can just times 2. Now, if that's the case, then I might as well don't write half, because half times 2 is just 1. Correct or not? So let's just don't write half. Let's just take 17.5 times 9. Anyway, Kaden, just now your calculation is not correct, okay? The final answer should be 157.5. The green triangle should be half of this, right? So this is the final answer. Questions, students? Anyone? Raise your hand. Now, what did we learn from this? If you see a shape that you don't really like, just cut it into a triangle. It's always easy to work with triangles, okay? Because you can look at the ratio of their base, you can compare the triangles. If you have triangles, it's much easier to work with, rather than trying to work with this funny four-sided shape. Okay? Now, let's start to do the practice questions. Everyone, can I give you 1 minute to give me the answer for practice 1? Type your answer in the chat. Just 1 minute is enough. Very good, Andriel. Very good, Aiden. If you can give me the answer in less than 1 minute, even better. If you can't give me the answer by 1 minute, there's something wrong. Find the butterfly. Once you find the butterfly, you get your answer. Come on. Yes, Nicole. Well done. Yes, Vishwam. Well done. Oh, Embriel, you have seen the question in another worksheet. Very good. At least you did your revision. All right. I think by now, if you haven't given me your answer, then you cannot find the butterfly, is it? Okay, I tell you what, students, you want to find the butterfly, you need to find your parallel lines first. Given that these two are squares, it is very easy for you to cut the square, like this. Do you notice if you cut the square, you always get 45 degrees? If you cut it in half, cut it like this, you get 45 degrees, yeah? So if both of them are at the same angle, they must be parallel. Now, where's your butterfly? Your butterfly wings are here. One green wing and one yellow wing. Okay? So that's your butterfly. So now that the question is already telling you that the yellow wing is 8, then what's the area of the green wing? So the area of triangle AFH is the same as the CDH, 8 cm square. That's why I say I only give you 1 minute to do this question, because you don't even need to do workings, right? Just find the butterfly and you're done. Okay, so the trick to finding the butterfly is look out for triangles that are connected. Can you see that these two triangles are connected? You see, they're connected at this point, right? They look like a bow tie now. If I draw a circle here, look like a bow tie, right? You see all the butterflies are all connected, you see? They are all connected like this. You see, two connected triangles. Then you should already suspect, could that be a butterfly? When you see the triangles connected together, you ask yourself, could that be a butterfly? You see, this one is connected at this dot. And that's how you spot the butterfly. That's how you suspect that there might be a butterfly. Once you suspect, oh, whoops. Once you suspect that there's a butterfly, then how do you confirm that it is a butterfly? Go and try to look out for your, man, what is this? Okay, go and try to look out for your parallel lines, then you can confirm that it is a butterfly. Okay? Then look for your parallel lines. Now let's look at question 2. Now remember just now, what did we learn? We learned that if we have two triangles, and okay, let's say this is 1:2, and let's say this area is 10 cm square. So I know that they share the same height. If they share the same height, 90 degrees, okay, I don't care that the triangle is slanted. Slanted, so what? I can still call this the base, right? Even if it is slanted, as long as the height is 90 degrees, then you're fine, okay? So if the ratio is 1:2, this is 10 cm, then the area should be 5 over here. Because the ratio of the base is equal to the ratio of the height. As long as, the ratio of the base equals to the ratio of their area. Okay? So, making use of this concept, they are telling us that the area of ABE is 64, AED is 32, CED is 35. So students, basically if you compare this and this, you will know that there are two triangles that share the same height. If I want to draw the height, then I'll draw a dotted line like this, 90 degrees. This is the height. So if this is the ratio of the area, then can I ask Vishwam, look at these two triangles. What is the ratio of their area? 64 and 32. What's the ratio?
2:1.
2:1. So can I say that the base is also 2:1? Yes?
Yeah.
Very good. Now you already know the ratio 2:1. Now I want you to look at this triangle 35, and I want you to look at this question mark. What do you think is the area of the question mark?
70 cm.
70. Very good. Because the ratio is 1:2. 35:70. So therefore, what is the area of the quadrilateral ABCD?
96 plus 105, which is 211.
Very good. Thank you, Vishwa. Okay, students. So you add everything together. There you go. That is the area. Okay. Now, students, anyone has questions about this? Now, let's try this one. Okay. Now, over here, I'm going to let you try it on your own. But before I let you try, let's take a look at what the question is trying to ask for. They have already given us A:B, 4:9. That's the ratio of their area. They want you to find the smallest possible area of the shaded region. Now, what does this tell us? This tells us that if you want the shaded area to be small, then you might as well make the area of C as big as possible. Then the shaded area will be very small, right? Okay, so can I just leave you for maybe 1.5 minutes? Try this question and tell me what is the smallest area of the shaded region? Your time starts now. Now, Talia, do you notice that these are square numbers?
Yes.
So if let's say the area of A is 4 and the area of B is 9, what is the side length of A?
2 centimeters.
And what is the side length of B?
3 centimeters.
Good. What do you think should the maximum length of C be? Should it be 5?
No.
What could it be?
4.
Oh, yes. Let's try to make it as big as possible so that the shaded region will be small. Okay. So can you tell me what is, okay, let's say area of C. What's the area of C?
10.
And what is the area of the entire rectangle?
35.
Yes. So therefore, what's the smallest possible area of the shaded region? Minus what?
3 minus 2. I mean, minus 16 for 9.
And what is the answer?
6.
Yes, you got it, Talia. Was this easy or difficult?
Easy.
Okay, good job. Students, anyone have questions? Raise your hand. Now, why do I not want to, you see, even though this is 4 and 9, right? Why do I not want to, try out other square numbers? Because they want you to get the smallest possible area of the shaded region. If you try any other square numbers, like for example, you want to change this to 16, 16 is to 81, right? Then I tell you the shaded region will be even bigger. Correct? Much bigger than 6. So we try to keep things as small as possible, okay? Now let's take a look at question 4. Again, I want to remind you of this concept. When you have two triangles sharing the same height, but they have a different base. Okay, let's say it is like that. 1:3. Okay, then if this is 15, this must be 5. The ratio of the area equals to the ratio of the base. So can I get Alistair? Alistair, can you volunteer for this one? Okay, Alistair. They are telling us that AD is to DC is 6:5, and this is a midpoint. So when I say that this is the midpoint, that means this must be the same ratio, 1:1, because you're cutting it into 2. So they are telling us that BDE is 10. Alistair, can you tell me what is the area here? Just compare these two triangles. Just compare these two triangles. Do they have the same height? Do they have the same height? They have the same base. So then what is the area of this?
10.
Yes, it has to be 10. Now, let's look at this yellow triangle. Oh, man. Okay, look at this yellow triangle. I would like you to compare it to the green triangle. Look at the ratio. Okay, now where is the base going to be? Now, where do you want the base of the yellow triangle to be? Should I say that the base of the yellow triangle is BC? Or should I let this be the base of the yellow triangle? We are trying to compare the green and yellow, right? So which one do you want to use as the base? DC or BC? Okay, let's use DC, okay? If DC is the base of the yellow triangle, AD is the base of the green triangle, then the height must be 90 degrees to the base. So let's draw a dotted line like this. So do you think that the yellow and the green triangle share the same height, Alistair? Are you there? Okay, looks like Alistair is not responding. Alistair, are you there? Okay, now. Okay, Alistair, are you? Alistair, are you there, Alistair? Yeah, hi, Alistair.
I can't actually really hear you because of this too much static, that's why.
What about now? Are you able to hear me, Alistair? Hello? Okay. Nicole, can you help me out with this question? Okay, Nicole, do you think the yellow and green triangle have the same height?
Yeah.
Yes, okay. If I were to redraw them, in a different orientation, if I were to redraw them like this, then it should look something like that. Okay, tell me what's the area of the yellow triangle?
20.
Okay, and so now I would like you to find the area of the green triangle.
24.
Well done. So we can say that 5 units equals to 20, and 1 unit is 4, 6 units must be 24. So therefore the green triangle is 24. There you go. We got the answer. What do you think? Was this easy or difficult?
Easy.
Easy. All right. Thank you, Nicole. Anyone have any questions about this? And that's why I always tell you, that's why I always want to remind everybody that it does not matter whether your triangle is slanted or your triangle is upside down or whatever. The base can be anywhere as long as your height is 90 degrees. Okay, that's what you need to look out for. Now let's take a look at this question. Okay, students, what are they trying to tell us? First, they're telling us that the square has a side length of 6 cm. So if I would like to find the area of the entire square, it's just 6 times 6, 36, right? Now, what else did they tell you? They tell you that BE is 2 times of CE. This is 2 times and this is 1 time. They are also telling us that DF is 2 times of CF, 2 times 1 time. Find the area of the shaded region. Okay, students, I tell you what, I'm going to let you try this, okay? But I'll give you 3 minutes. Okay, your time starts now. With this. Now, Malcolm, look, the shaded area is a quadrilateral, right? This is also another quadrilateral. We don't really like to work with quadrilaterals. So Malcolm, why not I do this? Why not we cut this into a triangle, shall we? Now,
Yeah.
Malcolm, I want you to look at these 2 triangles. Do you think they share the same height?
No.
No, huh?
No, yes.
Yes, they share the same height. So if I were to tell you that the area, Okay, let's say the area of the small triangle is 1 unit. Then how many units is the area of the other one?
1 unit.
Oh, so both of them same size, is it?
No, it's 2 unit.
Yes, 2 units. Good. What about this? What is the area of this triangle?
1 unit.
Yeah, correct. 1 unit. What is the area of this triangle?
2 unit.
2 units. Correct. Very good. Now, let's look at this triangle here. How many units altogether?
4.
4 units. Okay. Now, let me do something. 1:2, right?
Yeah.
I cut this into half. Okay?
Okay.
Wait. Okay, never mind. Let me just draw that line. Okay. Then I'm going to draw another line here. Now, my next question to you is, how many units is this triangle?
4 unit.
4 units, correct. How many units is the green color rectangle?
8 units.
Yes, because it is made up of 2 triangles. So the green color rectangle is 8 units. This is also 8 units. Yes.
Yes.
Total units for the entire square.
24.
8, 16, 24. Yes. So now we already know that the total number of units is 24. What is the area of the entire square? What's the area of the entire square?
36.
Yeah, 6 times 6, 36, right? So 24 units is 36. Now, next, I would like to ask you, how many units is the shaded area? You already know that the total units is 24. How many units is the shaded area?
18.
Very good, 18. Okay, because you take 24, minus away, minus 2, minus 1, minus 1, minus 2. That means you're minus 6. That will be 18 units. Okay, so from 24 units, you know that it's 36. I want to find 18 units. Okay, so now I already know that 24 equals to 36. 24 units, 36. You want to find 1 unit first, then you can find 18.
2 over 3.
You want to find 1 unit first?
It's 2 over 3.
2 over 3. Sorry.
Yeah.
Oh, that means you're doing this. Is it? You know that, okay, let me write
Oh,
it.
wait. 3 over 2.
Okay, so 1 unit equals to this. I don't like fraction. I don't like fraction. Can you tell me what is the highest common factor of 24 and 18?
12. I mean 6.
So instead of finding 1 unit, I don't want fraction. I just find 6 unit, can?
10.
Okay, 6 units is?
9.
Yes. Okay, so you divide by 4, you get 9. So therefore, the shaded area, 18 units is?
27.
There you go. Well done, Malcolm. So how do you find this? Challenging?
Yeah.
Or still manageable or not?
Yeah.
Okay, well done, well done. Students, anybody have questions? Please ask. Raise your hand. Okay. Nobody is asking. So let's move on to this one. Now, students, let me remind you of the concept. Okay, whenever we have a triangle inside a rectangle, what happens? The triangle is half of the rectangle, right? Okay, so why not we read the question? We are given all the areas there. They're asking you what is the shaded region. Let's do some labeling. Maybe I call this A, B, C, D, E. So they're obviously trying to ask you to find what is the area of B, the shaded region. Okay, so why not I ask Vishwam? Okay, Vishwam, help me out here. Vishwam, if I were to ask you what fraction of the entire rectangle is the yellow part? Half. So I can safely say that A plus B plus C equal to half of the rectangle. Yes or no?
Yeah.
Okay, very good. Then if that is half, then that means what about the green part? The green part, is it also half?
Yeah.
Half, right?
Yeah.
So can I say that A plus B plus C equal to 13 plus D plus 49 plus 35 plus E?
Yeah.
Yes, I can. But is it helpful?
No.
Does it help me? It doesn't help me, right?
Yeah.
Why it doesn't help you?
Because you don't know D and D.
Yeah, you don't know what is B, you don't know what is D, you don't know what is E, you don't know what is A, you don't know what is C. How are you going to find B? You can't. You are stuck. So why not like that? Let us not use the green color part. Let's use another part. Why not we use this green color part like that? Do you agree that this green color part is half of the rectangle also?
Yeah.
Okay. So instead of writing that, let me write down 35 plus A, 49, 13, C. Now, does it help you?
Yeah. And then B plus B plus C is equal to 35.
So, why does it help you? Because you have A here and A here, right?
Yeah.
C here and C here, right? All right. So now you can easily find B. Okay, can you tell me what is B? The final answer?
97.
97, correct. Well done, Vishwam. Now, Vishwam, I want to ask you another method of doing this. Okay, what if I decided to use this? If I decided to use this, so I'm going to write down D plus B plus E. Then what should I use? Equals to what?
49 plus A plus 35 plus 13 plus C.
So you are trying to use, are you trying to use this green part? You should use this green part, right, Vishwam?
Yeah.
So what are you going to write down?
35 plus is equal to 35 plus E plus 49 plus B plus 13.
Very good. So if you use it like that, then you can also cancel out your E and you can cancel out your D. So now you are going to be left with the same answer, 35 plus 49 plus 13. 35, 49, 13, same. Okay?
Yeah.
Very good. So Vishwam, do you think this is an easy question?
Yeah.
All right, well done. Students, anyone has any questions about this? All right. Now let's try out another one. Okay, everybody. Now don't be scared when you see this. Okay, don't be scared when you see this. It's just a labeling. Whenever we label things, we just use this. For example, if I have A, right? Let's say I have a point A. I have this point A. if I want to extend the line longer, so you see they extended the line longer here. If you want to extend the line longer and you have another point there, they just call it A prime. That's all. It is just pronounced as prime. Okay, and it is not denoted. It is denoted by a apostrophe. That's all. Okay, it is not a power. It is not a to the power of 2 or a to the power of 3. This is not a power. This is just a labeling, a prime. Okay. So students, we have a huge, okay, we have a big hexagon, which is A prime, B prime, C prime, D prime, E prime, F prime. And we have a smaller hexagon, A, B, C, D, E, F. So they are telling us that the big hexagon has an area of 9 cm squared. What else are they telling us? They are telling us that A, B, C, D, E, F are the midpoint. So midpoint means what? This is in the middle. That means these have the same length as this. This has the same length as this. And so on. Okay, students? Now they're asking you to find the area of the smaller hexagon. So why not I give you 3 minutes? Can you all try to find the area of the smaller hexagon? Your time starts now. Now the question has given us a hint. They are telling us that A, B, C, D, E, F are midpoints. So since we already know that these lines are of equal length, what we can actually do is draw a line. Okay? That means if this is 1 unit, this is 1 unit. Why? Because these two triangles have the same base and they have the same height. So they are of the same area. If I draw a line like this as well, I know that all of them will have the same area. Same base, same height, same area. Okay? Now, even if you compare, okay, this and this, they have also the same height and they have the same base, and therefore they have the same area. This has also the same base and the same height, and therefore the same area. Now, what else can I do? Now, let's take a look at this triangle compared with this triangle. Same base, same height, same area. Okay, so let me draw it properly. Let me draw this as well. You compare these two triangles, same base, same height, same area. And let me draw this as well. You compare this and this, or if you want to compare this and this, same base, same height, same area. Now, what else can we do, students? There's a big triangle here and I do not know how to compare. So let us use the trick. Let us use the trick over here. Make a mirror image. Let us make a mirror image. Ready? Make a mirror image. I take this triangle and I make a mirror image. That means they have the same area. Make a mirror image. Make a mirror image. So students, I've already drawn this. Everybody, can you give me the correct answer now? There are altogether 18 triangles here. So can you give me tell me what is the area of the small hexagon? Type your answer in the chat now, everyone. Correct, Vishwan. How about the rest of you? Okay, students, take a look. There are 18 triangles here, right? All of them having the same area. So why not I just say that there's 18 units? And the total area is 9, right? So 18 units is 9. How many units is the A, B, C, D, E, F? 1, 2, 3, 4, 5, 6. There you go. Yeah. Anyone has questions? Yeah, I know sometimes you need to, this really tests your visualization skills, students. Okay, you need to get used to the idea that sometimes you need to create your own lines. Not everything is going to be spoon-fed to you by the question, right? I know it can be difficult, but no choice, you have to get used to it. Now let's take a look at the challenging problem. Okay, I give you 15 seconds. Can you all just read it first? Yeah, read it first and try to understand it before you do it. Read it and understand it before I go through it with you. Okay, let's see what the question has given us, okay? Now, they are giving us ABCD, which is a rectangle. They already told us the area. Now, they have also told us that the triangle ADF, 2 cm square, ABE, 8 cm square. They are also calling this X. They are asking you to find the area of the shaded region. Now, students, if we can find this, then it's very easy, right? If only I can find this, then I'll just take 32 minus the white color parts. Then we know the answer. So now the question is, how do I find the triangle CEF? If you can find that, you will solve the question. Okay, so let's take a look. Why not? Why not we cut the entire thing into two? Why do I want to do this, students? I want to make use of the ratio of the base. Let me explain what I mean. Let's say that this is a yellow triangle, and let's say that this is a green triangle. They both have the same height. Correct or not, students? So if I know what is the ratio of the area, then I can find what is the ratio of the base. Yes? Now, if I cut this into two, then what can I say? I can say that the area of triangle ADC is actually half of the rectangle. And if I know that this is half of the rectangle, what about triangle AFC? It is simply 16 minus 2. So can I ask, okay, let me ask Talia. Talia, now I already know that the triangle AFC is 14, right? So can you tell me what's the ratio of their base? One is 2 cm, one is 14. So what's the ratio of their base? Can you tell me?
2:14.
Yeah, but I will not write 2:14. You must simplify for me.
1:7.
Got it. 1:7. Now, Talia, my next question to you is, what is the area of triangle ABC? Well, it is half of the rectangle, yes or no?
Yes.
What is the area of the rectangle?
32.
Okay, so what is the triangle ABC?
16.
Yes. Then if I already know that that is 16, what is the area of triangle ACE?
Uh, 8.
Yes. So if I know that this is 8 and that is 8, what is the ratio of the base? What is to what?
1:1.
Very good. 1:1. Very good. So now that I've found out all these ratios, let us draw a rectangle. I know that the entire area of this rectangle is 32, yes?
Yes.
I know that DF is 1, FC is 7. The ratio 1:7, yeah?
Yeah.
Can you help me to find the area of this rectangle over here?
Which? Oh. Uh.
Let's call this rectangle. Okay, never mind. I also know that this is 1:1, right?
Yeah.
Okay. Okay, never mind. Let me call this Okay, hold on. Let me call this rectangle X and let me call this rectangle Y. Can you help me to find the area of rectangle X plus Y? Because you already know the total is 32. And you also know this is 1 and this is 7. What is the area of X plus Y? Or if you want to use units, we can use units. Okay, do you think it's easier? Okay, let's see if
Oh
it's
wait.
yeah.
It is 56.
No, it's not 56. Okay, let's say that this is 1 unit. Then how many units is this?
That is 7 units.
Yep, 7 units. Okay, so total how many units?
8 units.
Okay, 8 unit equal to 32. 1 unit equal to
4.
and therefore 7 units is
28.
got it. Well done. Okay, another way that we can do is this, Okay, the more advanced way, The more advanced way is to just use fractions. You want to find what is X plus Y, right? X plus Y equal to 7 out of 8, right? Do you notice these 7 units out of 8 units? 7 over 8 of,
Yeah.
7 over 8 of the rectangle 32, right? And you will also be able to get the same answer. Divide by 8, divide by 8. You'll get 28. Okay. Now, can you tell me the area of rectangle Y?
Oh. 28 divided by 2.
Yes, 28 divided by 2. Because the ratio is 1:1 here. Okay, hold on. Andriel, yes, you have a question.
I don't understand why is it 7 out of 8.
Oh, okay, because if I were to draw a model, okay lah, I don't draw rectangle, I draw model. I draw model, okay? I tell you this is 1 and this 7. And I tell you that this 32. Do you agree that the total number of units is 8?
Yes.
Do you agree this is 7 out of 8?
Oh, okay.
Okay, very good. At least you asked. Very good. Students, it's always good to clarify. Okay, I'm glad you clarified. If not, you'll get very confused. So Talia, now we already found, okay, that this is 28. X plus Y is 28. Y is actually 14. Then can you tell me what is the area of this triangle? CEF? What is the area of this triangle? CEF, Talia, do you know? Oops, you're muted. Talia, what's triangle CEF? Okay, notice that whenever I draw this, I can also draw like that. Right?
Oh,
Right or not?
so
Ah,
it is 28. I
So-
mean, 14.
14 is Y. 14 is a rectangle, yes. Then?
Then 14 divided by 2.
Yes, good. 14 divided by 2, 7. Congratulations, you have just found 7 here. Okay, thank you, Talia. Students, if you already know the answer, please write it down in the chat. Okay, everybody, tell me the answer. What is the shaded region? The area of the shaded region equals to... Okay, type in the chat, please. Everybody. All right, Kaden, check your answer. NBL, you got it. Kaden, check your answer. It's already very obvious. Aiden, you got it. Kaden. Okay, can you volunteer for this, Kaden? Come. Now, Kaden, do you know?
32 minus 2 minus 7 minus 8, right?
Yeah. So you keep giving me wrong answers, eh? Okay,
Maybe
come.
I'm just careless.
Maybe. Okay, 32 minus 7 minus 2 minus 8. Come, let's do it.
Oh, I know already. I know already.
Oh, tell me. Okay, never mind.
15.
Correct. Very good, very good. 15 cm squared. There you go. Okay, students, so you already know that the entire rectangle is 32. They already gave you 2 cm and 8 cm, the white color triangle. We have found that the triangle CEF is 7. So you just need to minus all the unshaded parts. You get the shaded part, right? So students, this challenging question, it is challenging because you need to combine a lot of concepts that you know. If you need to draw your own lines as well. You draw your own line to cut it into half. Then later you use the concept ratio of the base equals to the ratio of the area. Correct? Then not only that, we even use the ratio of the length of the rectangle to find the area of the rectangle x plus y. Correct? We even needed to find this. And I did not teach you this during this whole lesson. We are only working with triangles, right? But you also need to think, this concept can also be applied to rectangles. 1:7. Then you can find the area of the rectangle. Okay? So it's very long, it's very long, but is there anything you want to clarify? Raise your hand. Anybody want to clarify any steps that you're not sure of? Raise your hand. Okay, so students, after doing this worksheet with you, what I realized that the butterfly concept, you understand the butterfly concept because butterfly concept is easy to understand. But what is difficult? It is difficult to spot the butterfly in the first place, right? Yeah, many of you had trouble spotting this butterfly. Then some of you also have problem spotting this butterfly, right? So even though we learn the butterfly concept, please make sure you know how to spot the butterfly. What else did we learn? We learned about the ratio of bases equals to the ratio of the area, we learned that if you see a triangle inside a rectangle, the area of the triangle is half of the rectangle. Okay, and we learn to create our own lines to make some mirror image. This mirror image technique is also used over here. We duplicate the diagram to create equal areas. Once you have equal areas, then you just need to count how many triangles you have. Then it's very easy. Okay, and that's it. That's it. You know, these are the things that we have learned today. So students, well done. We have managed to complete the worksheet. I hope that this open your eyes and give you some ideas of how to think out of the box. Visualization is a very important skill to have to solve geometry questions. Okay? So if you have any questions that you want to ask, you can stay back. Other than that, please do your revision and I'll see you next week, everyone. Bye, students. Bye, Aiden, Andriel, Gwen, Malcolm, Nicole. Bye.